Hello, my name is Andy Carson, and I am a data scientist with Matizia Consultants. I gave this presentation to my company back in October, and several people were interested in being able to see the presentation again or were not able to attend. So I decided that I would record this so that others could watch it and have the same content. So um, we gave this presentation over breakfast, and so it's a presentation on what is R, the programming language R. And also, as a little bit of an introduction, I'm going to talk about a little bit what is data scientists and why is it that people are interested in using R. So for a background, a lot of these terms are used to refer to the generally the same sort of thing. Data science, predictive analytics, data mining, big data, machine learning. All of these sorts of topics, while not exactly the same, do generally refer to the same sort of thing. So as I have put it here, these related overlapping categories are all about using existing big data or even just small data and modern technologies, algorithms, machine learning software, complex software, to generate new data or experiment on data or predict, classify, group, and model data for new business insights and improve decision making. So really what this is all about is that we have lots of data available now, a lot of it generated by machines, by computers, over the internet, and we also have the storage and computing capacities to be able to operate on this data and look at it and gather insights from it. So basically that's what all of this is about, is taking the large amount of data that we have and learning from it. And as a little bit of contrast with traditional BI, business intelligence, we're moving more away from, well, moving beyond, I should say, from what is, so more descriptive, to the why and the how. Why are things this way? How can we improve, a certain website setup or so forth? So let's look at some typical questions. Typical questions that would be answered in this realm would be, what will sales be like 1 year from now? That's typical forecasting. What factors are important in predicting sales? We're trying to isolate which variables are important that we need to keep track of. Why are patients readmitted within 30 days, and how can we identify these patients in advance? So this is a huge one for the healthcare industry, is being able to predict which patients are likely to come back into the hospital. And if you can identify these patterns, then you can intervene so that they aren't being readmitted. And this saves the hospital money and also saves lives and so forth. You probably have heard of A/B testing. If we change the design layout to A, will our customers buy more? How significant will that increase in sales be? So doing experiments online, one website layout versus another. What can we learn about our users from the thousands, millions, billions of tweets being sent by them? Are these tweets positive or negative in sentiment? So this would be natural language processing and doing sentiment analysis on text language, and being able to gather insights as to what are people talking about. Is it positive or negative? Is there any information we should be latching onto and grabbing? And can we determine a user's demographics based on his or her Facebook posts? If we know the sort of posts that a Facebook user with a certain demographic uses, then if we have the Facebook posts of another person and say we don't have any of their demographic data, we can predict what that user's demographics are just based off of other people's demographics that have similar Facebook posts. How can we recommend movies based on users' past movies watched? This would be what Netflix and other TV show sites like Hulu are interested in doing is how can we develop a model that will recommend movies that will be of interest to those that are watching. What products are bought together at our store? How can we package these to increase sales? This will be market basket analysis, looking at what items are bought together frequently and grouped together. The famous example is beer and diapers being bought together at the very high rate. So that would be useful information for a store owner. I give this example here was made famous on the Colbert Report, where Target was able to determine based on sales whether or not a woman was pregnant, and ended up sending some ads to a pregnant teenage daughter whose father didn't know that she was pregnant, and obviously was frustrated with Target until he found out the truth. So search for that if you're interested. So that's kind of what data science is about. It's using the new technologies and storage capacities and also just new data out there to develop more insights and to predict and analyze and classify. So R is one of those tools used for doing this. So what is R? Well, R is an open source scripting language used for statistical analysis, visualization, and reporting. And it's an alternative to Excel, SAS, SPSS, MATLAB, Octave, all these other sorts of, any sort of program that you'd be doing quantitative analysis. So it's an alternative. And it contains many powerful packages for quick data extraction, cleanup, transformation, analysis, and reporting. So these are the two links to get you going if you're interested in messing around with it yourself. What can R do? R can do a lot of things, and it's always growing, so there will be additional capabilities being added. But there's the standard programming that it can do, basic math operations, addition, subtraction, variable assignment, keeping track of variables and assigning new values to those variables, text manipulation like regular expressions, Boolean logic, control statements like if, else, while loops, etc. You can create your own functions and reference them in your program as well. You can pull data and export data within R from local files, web files, databases, HTML tables, other sources like big data sources like Hadoop. You can clean up your data, you can transform your data doing groups, joins, merges, various, pretty much any operation you might want to do. It has lots of very useful data structures. Data frames are going to be most like an Excel spreadsheet, table, columns and rows, with each column can have a different data type. You have lists, matrices, arrays, vectors. So there's just lots of different ways you can store your data and access your data. And one of the neat things R has is vectorization. So a lot of functions will apply the function to each element in, say, your list, and you don't need to loop through each element in order to have that function apply. So it's just a single step and also saves a lot of time. Data analysis, obviously, R needs to be able to do data analysis. So we have string manipulation. I already mentioned regular expressions. There's probability distributions, basic statistics like means and standard deviation, and you have significance testing, whether or not there's a significant difference between two data sets. Regression modeling, so you can do linear or nonlinear regression modeling. to do prediction, um, quantitative prediction. And then there's classification. If you want to predict whether a certain item belongs in this group versus that group. If you have already pre-labeled data that you can use to build a model, then you can, properly predict where the item should be put. Or there's clustering, which would be this would be unsupervised learning, where you're just grouping items based on whether they are similar. And then time series, obviously we want to see data over time. R has lots of graphics capabilities. So this is just an example of something I pulled off the web. So you can create very interesting charts and graphs right in R. And lots of more if there's something that you want to do, because it's all open source. Anyone can create packages and submit them. And when I had written this, there were about 6,000 packages and growing. So R is very flexible and capable of doing many things. So now I'm going to move to a little R demo where I demonstrate some of the R capabilities, and the demo operates on football scores, which I get from profootballreference.com, and all this data you can use to answer many different questions. So I'm just going to explore that in the next little video here.